Next, we want to take a look at how to represent relational database schemas. And there are a couple of ways to do this, and we will see as we're starting to use some of these concepts, we'll see a couple of ways, both of these ways several times. So the first way to look at representing relational database schemas would be a text-based representation. We can represent the relation by giving the name of the relation followed by the attribute names in parentheses and then underline the primary key. So here we have an example that says faculty, the relation faculty or the table faculty, and the attributes that that faculty has would be the fac ID, which is the primary key because it's underlined. Then we have the faculty person's name, their department, and rank. So a relational schema would also include domains, views, constraints, and other related information. So just a text-based representation of the tables that we have in the schema is only part of the schema itself. We can represent foreign keys by drawing arrows from the foreign key to the reference table's primary key. So now we have a second table listed, which is class. The class has a primary key of class number, but it also has a foreign key, fac ID, that points to the faculty table. So fac ID is the foreign key from class to faculty that represents this relationship between the class and the faculty member. Then there's the schedule and the room. So we can start building a series of foreign keys in this manner, and we see now that we have added the student, which has no foreign keys out to anything, but there is a foreign key that points to it. So we have student ID as the primary key of student, last name, first name, major, and credits. But then if we look at the enroll table, we have the student ID, which enrolls in a class, which is represented by class number. Student ID in the enroll table references the student table and the student ID in that student table. Class number represents the class, and it points to or references the class table through the foreign key class number, and it points to the primary key class number in the class table. Together, student ID and class number in the enroll table is the primary key. So in this case, we have one primary key that has two columns. It's called a composite primary key. And it takes both of those things to consider a row within the enroll table as unique. Because, for example, a student can repeat in that table because a student takes several classes potentially. And a class has several students in it, so that would also repeat. But the combination of the student and the class together should be unique, so it requires a composite primary key. And then we also have the grade that's listed there in the enroll table to collect that information. Well, a text-based representation might be good for a simple design or something that we're looking at that's pretty easy to review and easy to see. One of the best ways of visually representing a relational database schema is through the entity relationship diagram. Entity relationship model was developed by Peter Chen in 1976, and it's used for both database design and database representation. So it's known as ER or ERD, and ER is a visual representation of the entities, the attributes, and the relationships that exist. So let's take a look at some examples of the relational representation through the ER model. So there are three things that we need to know about. We have entities, we have attributes, and we have relationships. Entities are people, places, objects, things, events, concepts. anything that we collect and store data about. Attributes are the properties or characteristics of each of those entities. And then relationships are business rules that govern the associations between entities. So here we have a person entity displayed, and at the top of each of these boxes we will see the name of the entity, and then within it we will see the list of attributes for that entity. So we can see that that person has a person ID, which is the primary key. We underline it there. That person also has a name, a birthday, a street address, city, state, and zip. We add a second entity called car. Car has a set of attributes as well, and we can see that those are VIN, make, model, manufacturing year, manufacturing date, dealership, and the owner ID. The owner ID in this case is a reference to the person. So the owner ID will contain a person ID that says person 122 owns the car with VIN number whatever. So person owns car. Car is owned by person. This is a relationship, and we see the line now drawn between the person entity and the car entity. So let's look a little more closely at this. Entities are nouns. They are represented by or representatives of people, places, things, and concepts without description. So the name itself should be descriptive for what it represents. So a person, a car. They're pretty representative words of what types of data will be stored in the database about them. So they're represented by a rectangle in an ER diagram, and the entity name appears at the top of the rectangle. Within those we see the attributes. Those are also nouns or adjectives that describe an entity, and they're listed below the title of the entity. Underlining indicates that it is a primary key. Sometimes you will see these marked with PK, and then also if we have a foreign key, it's a dashed underline or it's marked with an FK. So either of those things would be true. So we have an entity type. So the entity type is the visual representation that we see here, person. That's an entity type because we see that all entities have a person ID, name, birthday, street address, city, state, or all entity types of car have a VIN, a make, a model, manufacturing year, date, dealership, and owner ID. Each of these is an abstraction of entity instances. So an entity instance is a single example of the entity type. So it's much like a row. Here's person with person ID 11245, whose name is Bob Smith, whose birthday is July 1st, 1982, street address 123 No Way, who lives somewhere in Tennessee 37999. Now, we look at the car and we see that here's the VIN number. The make is a Honda Civic 2017. It was manufactured on November 16th, 2016. It was purchased at Johnson City Honda, and the owner ID is 11245. And if we look that up in the person table, we see that the owner of this Honda Civic is Bob Smith. So this data is related through this foreign key relationship from owner ID that points over to person's person ID. So we can draw that relationship directly. We know that the car can only be owned by one person, so we put that person's owner ID in this particular field, and it represents this relationship between person and car. But a person can own a lot of different cars. So a person could be listed as the owner in this table several times. So The options here are called cardinality. It's the maximum number of times that an instance can be associated with an instance of the other entity. So a car can only be associated with one person because only one person can own it. But a person can own many cars. So this is represented by a straight line meaning one. So a car owned by one person, and a person owns many, which is called a crow's foot, many cars. And you have to read it in both directions. If you read it from person to car, it's person owns many cars. If you read it from car to person, a car is owned by one person. There are three types of cardinalities that we see. A one-to-one cardinality, where one instance of an entity is related to exactly one instance of another entity, and vice versa. We have a one-to-many relationship, where one instance of an entity is related to many instances of another entity. And then we have a many-to-many relationship, where many instances of one entity could relate to many instances of another. So in this next slide, we look at an example of a larger entity relationship diagram. Primary keys in this particular case are denoted with an asterisk. Foreign keys are not shown in this ER diagram, and they are not typically shown when they're used for database design. So sometimes you might see those listed and sometimes you might not. So we have one-to-one relationship called works in. So this means that the salesperson works in one office, and one office contains one salesperson. We also see modalities here. Modalities are the innermost symbol on a relationship. So this means if a salesperson works, then they will have an office. It is required for them to have an office. And they have at most one office. So they're required to have the office, and they have at most one office. But an office, on the other hand, is optional for a salesperson. An office might be empty, for example. So therefore, an office might not have a salesperson in it, but it would only have a single or one salesperson in it. We have two, in this case, one-to-many relationships. We have a salesperson sells to many customers, optionally, because a salesperson might be new and they may not have made a sale yet. And a customer is sold to by a single salesperson, and they're required to have a salesperson because otherwise they would not have purchased anything. And a customer works for many customer employees, and then that customer employee works for one customer. This is actually a special type of entity that kind of more fully describes a customer who is also an employee. We also, in this case, have one many-to-many relationship here. We have a salesperson who sells many products, and a product is sold by many salespeople. So we can keep track of that and say this salesperson sold this product this many times. So there's a set of things that we can tie to the relationship itself, and in this case it's the quantity. So if a salesperson sold 25 products of a particular product number, then we could store that as 25 in the quantity on the relationship itself.